Welcome everyone to the Technology Forum, or TechForum. This is our mostly monthly opportunity to get together, talk about tech and generally kind of geek out. Today we have Duncan, Principal Engineer from our ATS team, who's going to talk about how the cloud is other people's computers. Thank you very much.
Yes. So I'm Andy Duncan. I'm the Principal Engineer in ATS. I've been doing this for a while. A fantastic quote from Verdi I read recently. He said, "I'm no learned composer, but I am a very experienced one." As I get older, I realise the wisdom of that. This is one of the first programming books I ever had, ever owned. It's a Machine Code for Beginners. It's a great book. It's 6502 assembler on one side, Z80 assembler on the other side. You're counting clock cycles, amazing. All of these Osborne books are available online, free. You can get the PDFs of all of these books. They're fantastic introductions to programming. But these days, I don't really want to worry about the computer. I want to get on with solving my problem. That's why I'm in this game. That's why I do this. So I want to spend my time solving my business problems that I'm given and not worrying about managing computers. So recently, Jeff Atwood of Stack Exchange, Slack, Discourse wrote this blog post about hosting costs, comparing the cost of buying your own servers, hosting them in a colo facility versus the cloud costs, and it's far cheaper to run your own servers. He's quite right, it is. That is far, far cheaper. But that's also a bad way to use the cloud. That was often the way I've certainly done it. You've got your on-premise server, you wrap it up into a VM, and you ship it off to the cloud, and there we go. It's sorted. It's in the cloud now. But that's just expensive colo at that point. You're not actually getting the benefits of the cloud. Which brings me on to URL shortening. So when I was interviewing at ITV, the recruiter gave me some advice about possible things I might be asked. It's the same recruiter I've used in the past. So it's very useful as a candidate, very annoying as an interviewer. And one of the things he said, you might be given an architectural exercise, design a URL shortener. It's brilliant, fantastic idea for this. Turn up, sit down and interview, right, design a chat server. So I spent the first 15 minutes of the interview desperately trying to get back on course because it wasn't the thing I was expected to see. But this idea got in my head. I thought, it is actually quite a good idea. I do have quite a good design for this. I'm going to try this out. So it's my problem. Short links, all the rage. Everybody wants a short link. Got to have shorter links. Characters are at a premium. I want to build a system to allow people to create short links to URLs. They should be as short as possible, and it might be nice to allow people to choose their own short links for vanity URLs. So here's a possible solution. Using AWS serverless technologies, using generated IDs, that'll give us our possibility for vanity IDs. Nano IDs is a library for generating URL safe IDs that you can have the same collision guarantees as UUIDs if you choose them long enough. They're variable length. It's sort of minimal cost. I'm going to do all this in per use resources. It's not being used, doesn't cost anything. It's going to be secure. This is perhaps one of the greatest things about AWS. Free SSL certs. They self-renew. You don't ever have to worry about renewing an SSL cert. And we'll be using at-rest encryption on this. We'll get a very rapid turnaround of this, so we'll put changes through very quickly. And we're going to focus on solving the problem and not all the machinery around it. There are some downsides. We're going to see some extreme vendor lock-in here. This is going to be a high tariff of lock-in. And there's a trade-off we made there. Is it worth it? Is it worth the degree of lock-in to be able to do the things you can do with this? There's a loss of flexibility. If we don't want to do things the way that AWS allows us to do it, we're kind of stuck. We have to do it the way we want to do. And higher usage will be higher cost. The per request cost of this can get quite high. So if you're serving a lot of requests, it might make sense to build it yourself. So architecturally, it's going to look like this. So over here we have a person who wishes to shorten a URL, and then inside here there's all AWS resources. So we're going to be talking to CloudFront, which is the CDN in AWS. That's going to be going to API Gateway, which is a technology to build REST APIs within AWS. And then that's going to interact with a step function, a state machine in step functions. Step functions are fantastic. They're a way of doing state machines inside AWS, so all the work is done for you. It manages all the state and linking all the bits together. A number of times I've badly implemented a state machine and then suddenly discovered I do it out the infrastructure. We use DynamoDB for persistence. Used to have to pay an hourly cost for Dynamo. It's now per use. You can have a per use billing model. Over here, we've got the people who wish to see short URLs. So they're also going to come through CloudFront, through API Gateway. It's going to be a Lambda that's going to serve page them so they can see the short URL. So, let's see it go. Hopefully, this is the test. Can I get it to appear? There we go. So, here we are. We're in, this is a domain in Route 53. It's picked up. Got a HTTPS certificate. It's through. It is issued by Amazon. So, let's put the URL in there and shorten it. There we go. Short URL. It is, I admit, longer than the source URL. We'll come back to that. So let's just walk through what happened there. Let's look at the parts and see how we got there. So where are we? Here. So we started. Well, let's talk about what I'm using here. I'm using a framework called Serverless, which it manages a lot of the pain of managing serverless applications in AWS. So it's all driven through CloudFormation, but it hides all of that from you. You just write your functions. There's a declarative configuration file that sets that up. So we came in through CloudFront, and here is my CloudFront distribution. You can see here, I've got my domain name associated with it, got my SSL certificate, and it points to API Gateway. So to API Gateway. And here are my resources inside API Gateway. So I've got a post to /shorten, and then I've got a parameterized URL here, /shortid will return the short ID. So that's what we're seeing here. This request is being served by that resource. And then my API gateway interacting with my Lambda. So we can actually, in this page, we can test this out. So remember the format. I'm almost certain it's form encoded, so let's find out. Hate this keyboard. Should do it. Let's test that. And this is that request, so we can see this is the response we get back. So there's a multi-stage transformation. Request goes in, gets transformed, passes to the Lambda, Lambda does some work, passes back the response, and this is what we get back. And what we've got actually is a redirect, so it's a post and redirect sending us back. So if we head off to the Lambda, which I have already got open here, this Lambda is actually just a bit of glue that's gluing that request onto my step function. And now, get to the heart of it, step function. So I have this state machine defined inside step functions, and it looks like this. I love state machines, it's great. It draws the diagram for you and everything. This is all declarative, it's fantastic. So, start here, we've got some retry logic here. There's a dangerous thing here, this is reentrant, so this has got a loop in it, it's not acyclic. And it will happily run this infinitely, if you let it, if you get that wrong. And you can rack up some very high charge. I did try this out on my account. It does actually stop after 200 executions, so I desperately hammered on the stop button to stop it going. But it will stop. But if you're executing this very frequently, you can rack up huge charges very quickly. I've got a step here that actually generates the ID, and one that saves it, and then there's some error handling logic here that we'll look at in a minute that bounces back to the start. So if the IDs collide, don't want to get collisions in there, so there'll be an error, and we'll start again. It will generate a new ID and try again. So over here, we can actually see the executions of this state machine. So I can click in here, and that's what it did. This is the execution path through the state function. There's the input, and there's the output. So it's my short ID, number of retries. I can do this at each level, so I can go down through each of the steps, see the input, see the output, all the way through. It's brilliant, I love this. And the steps don't have to be lambdas. They can be Fargate tasks, they can be anything that can query an HTTP API. You can write your own long-running tasks that pull tasks off the queue, do some work, push it back again. They can run for up to a year, so you can have something really long running and then bring it back a year later, it all wakes back up, the state's still there, and you complete the execution. So we do actually have some code in here. There's some code I wrote in here. So fingers crossed we can get back to idea. There we go. Let's try and get this into presentation mode. This is always the challenge, getting multiple full screened things. There we go. And that's the entirety of the code I wrote to do this. So I've got my retry logic up here. I just have a retries counter. I've got the code to generate the ID, which is using nano ID. And I've got the code here to save it to Dynamo. And then I've got an expectation here that the ID doesn't exist, and that's the collision detection. That's it. The entirety of the code that I wrote. Everything else is declarative. We have in here the definition of the state machine. So we start in at the retry. This just sets up the retry logic, sets retries to 0. And then there's a choice. If the retries is greater than 3, we go to retries exceeded, which is our failure state. We've not managed to generate a non-colliding ID. There's a failure state there. That's not my code. This is in the state machine. Here's my retries exceeded, fail, and then it'll spit out an error page, and I'll just return a 500. But there's maybe some more error handling could be done somewhere else. I've got my code to generate my ID, code to save it, and here's my error handling for that. So this would be a DynamoDB exception. If there's an error of that type on this path, go back to retry card. So go back to the top. I haven't to write my own error condition. So going back to the okay, now we're stuck in full view here. IDEA is very opinionated about what should be full screen and what shouldn't. And now I've lost my browser windows. Okay, let's see if we can get that back. There we go. So we did have in one of our requirements was that the link should be as short as possible, and as we can see, is actually longer. So let's tempt fate and make a change. Down there. So got my tests here. There we go, here's my test. So, at the moment, we've got a test that's expecting a 10 character long ID. Maybe we make this as a function of the retries. So if we say, every time we go through this, if we failed, we'll just add 1 to the length of the ID. So maybe we'll say it's retries plus 2. Let's go with that. So retries plus 2. So it'll start as 2 character long, then it'll be 3, then it'll be 4, and then we'll fail. Maybe turn that number of retries. So, tests. Keep ourselves honest. Okay. Go in here. Yikes. Okay, so here's our code to do that. So we currently have a fixed ID length. So let's rename that to min ID length. This keyboard. It's okay. And we'll just add a bit of retries to that. Yeah. and we'll say we have minimum length of 2. So I'm desperately holding on to my 2012 MacBook Pro because I don't want to upgrade to this keyboard. Alright. Tests. Test pass, great. So let's commit that. And exit presentation mode. So, okay, that's what we're expecting. IDs. Let's make them shorter. Okay, and push that. Oops. Okay, to get on. Alright, so we've now got a branch there. We can create a new pull request on that. Pull request. Okay, and while that's happening, let's have a brief aside on wherever in my brief aside on CI. I've lost my slides now. There we go. I'm using GitHub for this, and I'm using Circle CI for the CI build. And I've also got Dependabot on here. Dependabot's fantastic. It keeps your dependencies up to date, so it can look at your dependencies file in your projects, understands understands Gradle, Maven, .NET, various flavors of JavaScript, requirements for pip, and it just opens pull requests with updated dependencies when you've got new dependencies. So you're never doing that 6-monthly cycle of updating all your frameworks and everything being broken. So it's just constantly updating it. GitHub recently bought Dependabot, so it's now free to use, and it's fantastic. Circle CI is a CI in the cloud. It's all based on Docker images. There's a declarative config file, which we can have a look at. So that should be building away now. So Circle CI is running my tests. Let's go and have a look at that. So I have this workflow building, doing a deployment to dev, and then I've got some integration tests, a Cucumber, just a happy path smoke test. So once that's gone through, doop, let's take about 30 seconds. Can watch it go. Oh, it's finished. So we've got some test results, ran one test, no failures. So now if we go back over here, we should be able to merge that in. Great. And now that's going to kick off another build in Circle CI. But this time, this is going to deploy all the way to prod. So I've got a conditional switch in the Circle CI config that will conditionally push all changes through to master if it passes all the tests. But meanwhile, over in dev, we should be able to go to there. And that. That's shorter. Fantastic. So. We could make additional enhancements to this. So we could report the number of views of each page. So in CloudFront, I've set this up to deliver the access logs into an S3 bucket. And so periodically, it's going to take all the accesses, pop them into an S3 bucket, Lambda there. It's then going to update my page count, and next time I reload the page, I'll be able to see that increment the number of counts. So that is, I have already actually done that. So let's pop back to. So it takes quite a long time to update things in CloudFront. So I did all of this ahead of time. So we should be able to see if we go to S3. This is delivering my access logs. They get delivered about every 5 minutes, so we should be able to see one soon. What time is it? And let's pop over to the code for that while we're waiting. Simple enough, streams out the encoded files from S3, does a bit of parsing, and just updates the document in Dynamo. And this is doing an add and incrementing it. So that's an atomic update inside Dynamo. So I don't have to worry about concurrency here. That's going to do an atomic increment on that number. So what we should now be able to see, if the logs have turned up, let's see if we've got logs yet. Not yet. Let's grab this ID and go and look at it in Dynamo. Go to DynamoDB. And ignore the meat tools thing, that's a different presentation. That one comes with dinner. Oh, in fact, it's there. So that's the document the initial saving put in. Hopefully, not too long. Do that request. Yes. Text bundles. They delivered every 5 minutes, but it's not the same. There we go. Finally got one. So if we now reload this document, we should see. Oh, we have to push that. Okay, has a page view. And now. So ordinarily this would be served at the cache. So there's probably worth mentioning here. The dev and the production environments are identical. They're provisioned identically. So there's no more cutting back on the capacity of your dev environment because, oh, it's only dev, it doesn't matter. This will perform identically. The only difference between this and prod is that I've turned up the cache timeout in prod. So most of these requests are actually going to be served at the CDN. So it will take longer to see the number of times it's been viewed. Should also mention, oh yes, tips on sort of while we were talking about CI. This is using the serverless command line to do this deployment. So there are AWS keys in Circle CI, and the usual advice is just give it admin keys because it's going to create all these resources. Just give it admin keys. I don't really want to put admin keys in Circle CI. So what I've done with this is I've created an IAM role that CloudFormation can assume. So Circle CI has sufficient permissions to start the deployment with that role, and then CloudFormation can use that role to create all the resources. That took a while. I ended up doing this with Athena and CloudTrail. So I ran it with admin privileges, collected all the the accesses together, grouped it all together, and there is in this project there is actually in this CI IAM YAML. This is a CloudFormation template that creates that role. So you take nothing else away from this presentation. Take this. This is it was such a pain to actually get this together, and there was no way I wanted to wake up and find that I've been mining Bitcoin in my AWS account all night. So if you take nothing else away from this, use this if you're going to use serverless in a CI environment. So that's counting URLs. Let's see, where are we? So the next step for this could be more analytics. So we're storing the access logs in S3. We could use Athena to then process those. So Athena is essentially Hive in the cloud, and it gives you I should still have the saved query I used to do the serverless stuff. Let's start a cloud trial and go through that. Cloud Trail just tracks all the activity, all the API usage in AWS. So it tells you all the things that have happened. See that there was a start execution on, what was that? On a function. Yeah, that would be the delivery of the objects into the bucket. Circle CI has used its keys to start the deployment, so it's doing some things around that. You get this big long list of all the things that have happened in your account, all the API interactions, and I've got this publishing into an S3 bucket, so I could then use Athena, as it helpfully suggests, to query those. So where's this link take us? Okay. So this is the Hive table you would define that reads the structure of those events. Go over to Athena. Run it. And hopefully my saved queries are still on this computer and it's not done. Yeah, there we go, great. So that's the query. I'm just querying for the identity, the event source and the name, where it was like Circle CI. So let's just run that. There's a Hadoop cluster in the background that's managed by AWS. I don't have to worry about that. Don't have to worry about keeping all that stuff running. There we go. That's all the things that Circle CI has done to do those couple of deployments we just saw. And what's interesting about Athena is that the pricing model is based on the number of bytes it reads to serve your request. So if you can partition your data, and you can set up partitions within Hive, so you only have to read a subset, or you can compress it. It'll read gzipped files, and that's kilobytes. You can get really, really cost-effective big data queries across large amounts of information. It's really interesting. I'd love to have a real problem to solve with this, because it's really neat. But we could also use this to do deeper analysis of the access logs and get more of a dashboardy thing for more administrative users and see what our usage patterns are over time and who's shortening what and what they're pointing it to. We could also implement the vanity URLs, so that would be switching out that generate ID function. So we just change that ID generation strategy. If there's a supplied ID, pop it in there, otherwise you get the same functionality. If it bounces out to the top, you can start adding numbers to the end of it. We could also look at user management. AWS has this Cognito, which will handle both identity and authorization. So you don't have to worry about hashing and salting a password ever again. It's all done for you. It'll plug into, it's an OpenID provider, so any OpenID provider plug into it. You can now do that at an ALB level as well. So ALBs, application load balancers, you can have those do your authentication. You have any OpenID provider plug into ALBs. It's all just done at a load balancer. Fantastic. I haven't tried that out yet. That's probably where I'm going to take this next. Look at all the things we didn't do. I didn't provision any hardware. I didn't configure any networking. I didn't start an instance. I didn't patch anything. I didn't even build a container. We can have that discussion later. My deploy was a zip file. Serverless deploy was just a zip file. Just the code zipped and copied up. And this probably represents 6 to 8 hours of work, excluding finding out what the serverless permissions were and some dead ends around asynchronous loading. that's something I stood up in an afternoon, and I've tinkered with it over the course of the last few weeks, and so there's actually not a lot of my time has gone into producing what is a URL shortener that will scale as well as Amazon will. And that's why cloud is other people's computers, and that's the best thing about it. Any questions? I'm sure there must be something.
Why do you want to put us out of a job?
I want to make our jobs more interesting. And that's a good point, and that does represent what would have been a lot of people's jobs. And we can get into the morality of software and what we do as people and how it affects society and how it affects the people around us. But look at the effectiveness of it, the things you can achieve. You literally couldn't do 5 years ago. You couldn't have done this 5 years ago. And that's what excites me about this. Is it's not spinning up 1,000 servers in a minute. It's never starting a server. It's building things out of high level of abstraction, building blocks and fitting it together against complex behavior, and then all I have to do is put in my business logic. And I'm putting my business logic into a lot of somebody else's stuff, and that's where the vendor lock-in comes in. And there are things you can do. You can defensively protect your code and have it work at the library level, but the speed at which you can get up and running, you stand up a serverless stack in minutes and get Hello World going and start poking at it. Just start building on it and building on it and building on it. But yeah, it's something we should generally thinking of as technologists is how does what we do affect the world?
It's a car instead of a faster horse.
Yeah. And maybe it's a smaller car than the horse could have carried. We'll work on the metaphor. Other questions? Anybody? Okay. Oh. Yes.
So, cybersecurity.
Hello.
Let's say Amazon has a big vulnerability. Is that an acceptable risk for people's products and software that they make? You know, compared to having it manageable locally somewhere that we can control.
Sure. Yeah.
Or would you?
So in terms of the managing the security risk and managing the threat models, frankly, I would trust Amazon far more than I would myself to secure these things. But they're now, I think, across everything in Amazon, in AWS now, you get at least encryption at rest, and most of them have encryption in flight as well. So whatever you put up there is protected from Amazon and from hopefully any attackers. You can provide your own key material if you want to. It costs more money, but you can have everything encrypted in there. And that dynamo table is actually encrypted. So that is. I would have more faith in Amazon's capabilities there than I would in my own. Although it's interesting, there's a thing I saw recently that Hewlett-Packard's cloud, which they used to have, was exploited by mysterious third-party, possibly state-sponsored attackers, and a lot of their customers were exploited. You can't ignore it. It is. You're putting more faith in AWS at that point, for sure.
So it's the Circus CI config.
Oh yes. Let's go to. Okay, hang on. Which bits do I need to not full screen?
I just want to watch you play for Windows again.
Did I minimise that? Maybe I minimised it. There we go. So serverless YAML. Step through this. Some AWS configuration. This is where it's pulling in the role for deployment. I've got a couple of things I set up ahead of time. So in parameter store in configuration manager, I've got my domain and the ARN to my SSL certificate, and a bit of configuration per environment per stage. So I've got the definition of the domain names for the two stages, and then the cache ages parameters that I've set there. some permissions for the functions there, so that lets them interact with Dynamo and start the state machine. The events stuff is rare. So this is how you define a function. So this is my shortening forms. This is the form where you put in the URL, and that's all you have to do. And it'll handle everything else. It'll create the lambda. It'll create the API gateway. It'll create the resources. It'll glue it all together, turns it into standard CloudFormation, and just dealt with. 12-factor app. So it's all environment variables. What else? And then there's the definition for the state machine is down here. There are some awkward things like S3. Where's the process examples? Serverless wants to create your S3 buckets for you if you have S3 events. I don't want to do that because I want to reference it in CloudFront. So you have to do some things when you're going outside of the confines of serverless, the default stuff. You do have to start doing stuff yourself. And somewhere down here, I've created a bucket policy for that S3 bucket. And this has to follow naming conventions. It's a bit awkward, but I think it's worth it for not having to do all of the rolling all the CloudFormation yourself. And you can add arbitrary resources. So in here, I've also got all my other resources: my Dynamo table, bucket, the CloudFront distributions defined in here as well. So this just adds it onto the CloudFormation template, and glues it all together, and then updates a Route 53 record at the end of it. So it's all completely self-contained. It's all within this project. So nice. Oh, sorry. Yes, we were talking about Circle CI. So, yeah. So defining a workflow has these jobs in it. So build will run tests and build the artifact. Deploy deploys it within a context of AWS. That's where my keys are. There's an idea of context that's set environment variables. Runs integration tests and then deploys it to prod if the integration tests pass, but only on master. So that's how that's done. And then the jobs down here defined using Docker images or running Docker images. Circle CI provide the standard one, so you get a node one. You get you could also cache dependencies under a checksum. So if you checksum the dependencies file, you can then pass that around between jobs. It stops you having to download the whole world when you first run a job. So you run Maven on a clean build executor and you have to download all your dependencies. You could checksum your POM XML and not do that. And then my integration test also runs on a variant of the node that has the browsers installed on it. So it's got Chrome on it. Integration tests run through Selenium. We're using Cucumber, and that's all just handled. You can build your own images. You can bring your own images if you want. If you've got something custom, you can install stuff on them, so you can run commands on them, store test results, and pass artifacts between steps. It's really neat. It's really neat. Thank you.
That's really cool. Nice. So I guess my job.
It's terrifying, isn't it? Absolutely terrifying.
Yeah, that's great. I think it's kind of what I said about having a car instead of faster horses. I think there's a load of bits and pieces of plumbing there that actually, like you say, you can go straight into delivering high value work instead of toil. So
yeah,
definitely can see that. So yeah, that was the TechForum. That was your first time here. So this is kind of short, sharp, brilliant tech talks from people inside and outside the company. If you'd like to speak, please give me a shout in Slack. I'm Tom Clark.